Hello everyone. In this class we are going to learn about the force and torque experienced by dipole placed in uniform electric field. Before learning this concept, you should know some of the basic things like what is dipole, what is the force experienced by single charge placed in electric field. Okay, first of all, what is dipole? See, dipole is the combination of two charges. Okay, two equal and opposite charges. Let's consider that is q and minus q. Two equal in magnitude but opposite in polarity. Two equal and opposite charges separated by small distance. How much is that? 2a is called a dipole. Okay, the distance between the two charges will be very small and that is represented by 2a. Then second thing is, what is the force experienced by single charge q? What is the force experienced by single charge q placed in electric field? That is given by F is equal to q into E. Do remember these two. Force experienced by positive charge can be written as plus QE, and force experienced by negative charge can be written as minus QE. Okay, and by using vectors also we can write plus or minus there. So now first let us discuss about force experienced by dipole placed in uniform electric field. So what is uniform electric field here? Uniform electric field is represented by equidistant parallel electric parallel lines like this. So inside that I will place the dipole. Okay, so let us consider this is positive charge, means plus q, this is negative charge, minus q. Okay, so this is electric field line. E represents electric field lines moving in this particular direction. Now force experienced by this charge will be along this electric field, that is given by F plus is equal to, in vector form, F plus is equal to Q E vector. F is equal to QE. And force experienced by this negative charge is given by F minus is equal to minus QE. So this is force experienced by positive charge, that is given by QE. Force experienced by negative charge is given by minus QE. Okay. So this negative sign represents here that F is, that means force experienced by negative charge is opposite to the direction of electric field. Here force experienced by charge is along the direction of electric field, so I have written plus sign there. Now the net force experienced, the net force experienced by dipole is given by net force is equal to force on positive charge plus force on negative charge. Okay, so that is equal to force on positive charge is QE. I will write the magnitude itself. Okay, so plus force on negative charge is minus QE. So that gives 0. So the net force experienced by this dipole is 0. Do you remember that? Okay dear students, we got to know that the net force experienced by dipole placed in uniform electric field is 0. So I will write here F net is equal to 0. Then what about the torque experienced by dipole? What is the torque experienced by dipole placed in uniform electric field? See, we know that torque is given by force into perpendicular distance. Okay, torque is given by force into perpendicular distance. Here I will write the magnitude of that, force into perpendicular distance. Okay, this force is the magnitude of any one of these forces, okay, experienced by single charge into perpendicular distance. We know force experienced is Q into E, magnitude of this one is Q into E. Then what is perpendicular distance? So if I consider this one is fixed, because of the force experienced by this charge moves like this, and this negative charge moves like this. Let's fix this one. This charge moves like this, means this dipole is moving like this. So 2a is the distance between two charges. Now, here, if I consider this one is the perpendicular and this one is the base, this angle will be 90 degree. Now let's consider this is the angle theta made by dipole with the uniform electric field. Then we can write sin theta is equal to what? Opposite by hypotenuse. Then sin theta is equal to opposite divided by, what is hypotenuse? Hypotenuse is 2a. Okay, let us multiply this 2a this side. You will get 2a into sin theta is equal to opposite. So this opposite side is of length 2a sin theta. So that is the perpendicular distance. Perpendicular distance. Okay. Now torque is equal to force. Magnitude of any one of the forces is Q into E into perpendicular distance is 2a sin theta. Dear students, here torque is equal to, here we have one more parameter that is called dipole moment, that is 2aq. I will write here 2aq one term and E into sin theta. This 2aq, magnitude of any one of the charges and into the distance between the two charges is called dipole moment. So torque is equal to P into E into sin theta. So that is given by P cross E. So the net force experienced by dipole is 0. The torque experienced by dipole is P sin theta or P cross E. Thank you. We'll meet in the next video.